All right. All right. We are going to begin. I guess if anyone joins late, they can catch the whole thing on YouTube post afterwards. My name is Holliday. I'm an acoustical consultant. The goals here are to understand environmental noise studies. This is going to take about 20 minutes. Feel free to put any comments or questions in the chat box to the right, and I'll answer them as we go if I see them in time. The goals are to talk about analysis, compliance, and mitigation. I'm actually with Sound Solutions Acoustical Consulting. I'm an acoustical engineer, registered professional engineer. I did my master's in acoustics, and at Purdue it was in mechanical engineering. Member of National Council of Acoustical Consulting, Acoustical Society of America. Used to work for an active noise control company, and then a consulting firm in Portland and Denver. Big engineering firm here in Arizona that was bought out by AECom, like many other firms are. And I started Sound Solutions in years ago, probably more. General noise study steps. So really you're driven by what the regulation says. That'll dictate how you go about doing these noise studies. If they say to measure the existing, then you measure the existing. If they say you don't need to, depending if it's contentious, it might be worth doing. But you don't need to if they don't say you need to. Usually what you're doing is predicting future. Sometimes you're just measuring to see if they're in compliance. But a lot of times for proposed operations, you're predicting that proposed future noise. And then you're comparing it to whatever the guidelines are that are driving that area. And then if needed, you look at mitigation. I usually tell clients, you can knock the noise down by as much as you need to. It just becomes a question of cost and operation, whether it's worth doing. But you can usually solve any problem, any acoustic issue. I mean, put a dome over it, but there's cost and logistic issues that might get in the way of complying. Let me hit some examples here. Some projects are very well laid out what you need to do. Road projects are one of those. In the state, city, county, if it gets federal money, you're going to have a regulation that's real clear on what you need to do, the program you need to use. Airport noise, that depends on the community you're dealing with. Some are very clear. Some are a little bit more up in the air. A lot of times this is just you want to build an office or a home in a noise zone. So they have to do, or airports need to provide the day-night limit or levels around the airport. And if you're building within a certain zone, a lot of times there's rules for what kind of construction you need to provide a good environment indoors. Again, depending on the community, can be real clear, can be a little vague. Commercial, industrial noise sources, that is all over the place. Some states, Colorado, Oregon, Massachusetts, Utah, I believe, they all have state regulations, and you have to meet that throughout the state. A lot of other states have city by city, county by county rules, and they can be very clear, they can be ridiculous. HUD, very well defined. They even tell you what programs to use, they provide them, and you run through their steps to find out if a housing project is in a zone where either it's an acceptable acoustic environment or it needs additional treatments, exterior, windows, wall, roof. So regulation examples. I actually have a lot of these. So again, the Department of Transportation is very clear. They'll give you, tell you the program to use, the traffic noise model. It's free. You just download it and use it. They tell you what the limits are, depending on who's funding the project will drive the limits you have to use. So if the county, it might be similar depending on what state, county, or city you're dealing with, but a lot of times they'll vary, and so they'll have a little bit different limits. They have an overall limit. The future level can't be above a certain amount. They also have a change criteria, so it can't increase by a certain amount. And those can vary, the absolute limits and the amount that it changes. Those can vary a bit from state, city, county. But you just go through the process. You predict you measure the existing, you predict the existing, make sure your model's working. You predict the future with the traffic. Traffic engineers give you traffic data. Usually it's some county traffic projections. You plug those in and see if it meets the criteria. If it meets it, you're done. If it doesn't meet it, then you have to look at mitigation. And then usually mitigation is very clear as far as you have to benefit the receivers or the houses or schools, whatever the receivers are. You have to benefit them by 7 dB or 5 dB if it's not a front row. Or, and then they'll give you a cost. They'll say, hey, you can only spend $35,000 per person or $16,000 per, whatever their limits are, and they tell you to use $20 a square foot for the barrier cost or $30 a square foot. They'll give you all that information. So you just follow their steps, very straightforward. Some regulations are super unclear. We have got in a lot of places we've worked, California, Arizona, well, we've worked in a lot of areas, but some of the regulations in Arizona, there's a city that uses a 24-hour average noise limit. So you can make a ton of noise at 3 in the morning, and then if you're quiet the rest of the time, you'll comply. Some cities have a maximum limit. So it's a high level, like 70, but it's a maximum. So no door slamming or just any instantaneous event could theoretically throw you over. Maricopa County is a great one. It just says you can't hear the noise inside a closed home. Flagstaff, similarly, it's no audible indoor levels, and it just makes it real unclear what limit you have to achieve at the property line. I mean, it doesn't help the businesses, doesn't help the homeowners where you can get an audio recording with your windows and doors closed, and you can make it out dead silent in the house, and you can make it out done. They've exceeded the limits, and we've been to court cases on that, and that's the law of that community. Typical regulations are around 50 during the night, 55 during the day, with some variations, 45 in some communities, 55 or 60 during the day, but in that range of 50 at night, 55 during the day. And a lot of times it's a 1 hour average, but you'll see regulations that use statistical levels. They'll use, some of them do have, you measure the existing and you can't exceed that by more than 10. But when you're predicting the future, you model and you look at what are the noise sources from, let's say they're putting in a Lowe's, from their garden, their delivery trucks. What are those noise sources? When are they going to occur? For how long? And what's that level at a known distance? And you can predict it at further out at the noise-sensitive receivers. Airports, like I said, some of the projects are determining those noise contours, the LDN contours, and then some projects are construction within the contours. There are sometimes exemptions for regulations. If there are certain types of events, you can get a variance or get an exemption to the rules. Construction oftentimes is exempt. Yeah, I think that's mainly. We've had a lot of these cell tower projects. Noise source is just air conditioning or emergency generator. And sometimes emergency generators are exempt, sometimes they're not. This is the traffic noise model. You put in coordinates of the road, coordinates of your receivers, put in the mix of traffic, how many trucks, cars, or heavy trucks, medium-sized trucks, automobiles, and the speeds, and you can get some, pretty good levels, or at least that's what they want to see at future levels. We have to do significant increases, doubling the amount of traffic only moves the noise level up 3 dB. Airport contours, again, if you're constructing within some of these zones, certain communities will require, oftentimes, noise mitigation. And then if you know the flight paths, types of planes, you can come up with those noise contours. Measurements, what do I want to say there? Or methodology. So measuring, you model existing future, verify your model is usually what you're doing with measurements, or you're just trying to determine compliance. But a lot of times you'll measure the existing, and then if they're going to make changes, at least you've got a good base with that measurement. As far as noise mitigation, you really only have 3 options. The source, treat the path, or treat the receiver. So treating the source, you can replace equipment, you can do maintenance on equipment, silencers, move equipment. Maybe you have a big piece of equipment, and if you can move it to a couple of places, different places, that could help the overall level, or relocate them behind a building. Road noise, you can reduce the wheel-road interaction with rubberized asphalt, concrete, although that has some maintenance issues. And replacing equipment, location of equipment, even orientation, how you direct the noise. A lot of times it's different coming out of each side. Treating the path, a lot of times we're limited to barriers, although they can be transparent. Lots of different types. Really, barriers end up being the type you use. Usually the issue becomes maintenance, durability. And then treating the receiver. I guess this is also the path. You can add absorption to like an indoor range, and that would help the path. Receiver, just treating the person. Sometimes on architectural projects, the path, or the receiver, I guess, would be treating windows, doors, exterior paths. Enclosing, and that's kind of the path, but it's also the receiver, keeping the receivers in a booth or in a enclosed office within a factory. Briefly, this is an example of a project, a mine. We're measuring reference noise levels, so we knew the levels from equipment at a given distance. And then with that reference levels, if we know the type of operation, how often they're operating, what equipment, we can predict that further away. So we can predict it up at areas of concern. Wildlife acoustics, you will see that as an issue. That is, I don't know, we've had projects with sage grouse because they make noise to attract a mate and breed. If a mine or an operation is masking that noise, there could be issues with their reproduction. And so we have to monitor. We can't be right at the breeding area, the lacs, but we can be near. And they don't want people out there, so we can't sit there and observe. We have to radio in the data, and then from the spectrum determine what the noise sources are and meet their criteria. So we end up looking at the spectrum, determining if it's bird noise or if it's wind noise, trying to correlate it with different events, looking at the different time series. But it's really, there's equipment now that makes it, you can always audio record it. That just takes a lot of time to go over. So usually what we've done is you look at each hour. If there is a violation of the criteria, then we'll look at the spectral time data. If we can clearly identify that it's not from the mine, it's from a bird, or it correlates well with wind, then if it's not correlated, then we can exclude those. If we still are not clear what the source is, then we can just listen to the audio recording for that stretch instead of trying to listen to audio recordings for everything that's measured every day. Hey, we're acoustical consultants. We're independent. We do environmental, sound, impact, isolation, room acoustics, mechanical noise, anything related to noise or vibration. And yeah, we actually do some, if needed, we'll give you an evaluation, make recommendations. If someone wants further assistance, we can actually install treatments. Noise expert is a DBE. So if there's government projects, we have a little bit of an advantage for a team if we're to be teamed up with. All right, I'm going to leave it there. It's about 20 minutes. The noise engineers.com, did I spell that right? Engineers.com /. I'm putting a link on the chat for the free updated ebook. There we go. Okay. Other organizations, we're members of this, but National Council, NCAC.com, I believe, is National Council of Acoustical Consultants. That's a good directory for acoustical consultants. And ASA is the Acoustical Society of America. INS is Institute of Noise Control Engineers. Equipment needed to deal with acoustical projects is usually a sound level meter calibrated. Sometimes we need loudspeakers and recorders, but that sound level meter is our base. You can use a phone app sometimes, but that is really, phone apps are really just for, they give you an idea. They're not that good at low frequencies or at high frequencies or at high levels or low levels. But if it's voice, moderate levels, they can give you a good idea. And you can get even a spectrum analyzer app on a phone. And you can get an external mic to get a little bit better resolution. That's a lot cheaper tool than the calibrated sound level meters that we use. Well, let me know if, oh, here we go. I'm trying to build a decimal meter out of an Arduino, Android, maybe? I'm not sure what you're trying to build it out of. I've never built one, but usually they want it to be a type 1, type 2 to meet regulations. But if you just want something, an Android, yeah, just download an app. There's a ton of sound level meter apps. And again, they have their limitations. You can't calibrate it. The microphone for these, I'm looking at mine right now. For a smartphone, it's this tiny microphone, so it's not going to do well at low frequencies. But it's, oh, it's a microcontroller. Okay, I'm not familiar with that. I'm not sure. I mean, I'm sure you can program it. There's easy apps on smartphones or on tablets. You can connect just an input signal, a microphone signal in and analyze it. So that's not, I see no issue with that. It's just if you want it to be certified and calibrated, you have to kind of go through some hoops there, I guess. Okay. I want to log sound over time. Sure. I mean, and sound level meters will do that too, but it's probably cheaper, I'm sure, doing it yourself. So the sound level meters, I mean, they could do multiple days. We have them out there for a month at a time out in the field. Big car batteries keeping them going, and we take the signal from phone signal. But, or you can even just audio record it and feed the wave file to get some hourly statistical data. But yeah, there's lots of options out there. It doesn't have to be crazy expensive. All right, I need to go. I have a meeting. Please feel free to email me, contact me if you have any questions or concerns. I hope this is helpful. Not always clear who my audience is, but I hope I'm reaching people that need some help. You're welcome. And our site is noiseengineers.com. You can poke around there and let me know if you have any issues. All right, take